This is our fourth entry into KLEP and the KLEP ecosystem. Today we go deep into keys and the property manager, both of which are utilized by the key loader. Keys are a critical component in KLEP's interactions. Keys have the ability to enhance these interactions within the KLEP system by carrying information. This information can be strongly cast by hard-coding what information the key can carry. However, we can weaken the system, as in make it more dynamic and not as rigid, by enhancing a key's ability to carry any information we want during initial design, down the road, or during runtime. That is the goal anyways. As this is the newest addition to the KLEP system, it's full of bugs, full of misunderstanding, full of Dwarf Fortress-like fun. Thus, while I will go into the code, I will be explaining it to the best of my understanding, and that may or may not be what's actually going on, because the two states of coding are, I don't know why my code doesn't work, and I don't know why my code works. In the next video, we will talk about our key manager and /key loader. At a glance, the key manager is responsible for releasing keys into the neuron, managing the keys' life cycles, and making sure that the keys are used correctly in the neuron. But where do these keys come from? /key loader issues keys with properties managed by the property manager that the key loader has been set up to handle. So think of you, the designer, as the guy who comes by and loads up products in one of many vending machines. You decide if the vending machine is going to vend candy bars or if it's vending soda. Then when a customer comes by, an executable, who needs a snack, a key, to share with the office, the neuron, it makes its selection from the expected flavors, the properties, of goods in the vending machine, gets the vended snack, returns to the office to share it. This is the essence of the interplay going on with keys, the property manager, and the key vendor. So let's begin. Fair warning, I'm going to say properties a lot, as keys are scriptable objects in my implementation of a KLEP system. The on-enable function behavior is different than other scripts. It fires whenever the object is selected, and due to this, safeguards are in place to prevent it from initializing overset data. Our first two checks here are to see if we have a property manager and if it's pointed to a key loader. If it is, then we check to see if the key's property manager has custom data present, such as values that differ from the default values of the key loader. If it does, then we assume that this is intentional, and we do not initialize it to the default values. Otherwise, for safety, we do. If we do initialize our properties from the key loader, we call the initialization function, which clears out our list of properties and reinstates them from the key loader. Then we load in each default property from the key loader, which holds its unique list of property definitions. These are the actual properties that are defined, such as bools and vectors. So why is this special? Let's say you're developing a role-playing game that features a bunch of items, spells, and abilities, and each one is represented by a KLEP key. These keys are used to unlock different capabilities or interactions within your game, and each key is associated with a /key loader, which defines its properties. For instance, loader A might be configured for offensive abilities, defining properties like damage, range, and cooldown. Loader B might be designed for defensive spells, including properties like defensive boost, duration, area of effect. Let's say a mod developer decides to create a new spell that combines aspects of both offensive and defensive, something that wasn't originally envisioned. They can create a new loader, loader C. This new loader could include properties from both loader A and loader B, or entirely new ones, like mana cost or something else like that. Then they can assign this loader to an existing or new KLEP key. When this key is selected or loaded, it dynamically inherits all of the properties defined in loader C, thanks to the initialization process. So when you change your system and add more stuff, you don't have to throw away things you've already developed. Those things will automatically adjust to fit what you've come to for your design flow. We have two more functions living in KLEP key, and that being of set property and get property. These call the property manager as it manages properties. Oh my gosh. To either return the value or set a value to a property. A string is passed in to aid in debugging if need be. The property names are strings, which are prone to typos and mistakes. However, as we'll see in a second, our property definition allows for two types of names. A strong casting naming convention, where we make the use of enums to manage the name of things, or a weak naming convention, where we as designers or the machine itself can assign a custom name. In the property manager, we have already glimpsed at one of its functions, has custom data. To more thoroughly look at it, we can see that it begins with some error handling. It then moves to a loop that checks its currently held property definitions against what properties are governed by the assigned key loader that the key is assigned to. I know that was a dense sentence. If it finds something with values that don't match, or a property that is not natively assigned by the manager, we assume that this is custom data, and we return a true, that we do have custom data. And as we've seen before, this means we will not overwrite that data with the default values. We then have the set property and get property methods where the real work is done. The key loader governs a list of properties that are parsed when calling the set property or get property. This returns the first one it finds with the matching name to the property manager's held definitions. Next, in the case of set property, if it finds the property, it sets the value to the value that was passed to it. This is a value of t generic, which allows us to pass in anything we want, as long as we have properly told the property definition how to handle them. This could be a list of booleans or a hash set of coroutines. It could be anything. If the property is not found, it checks if the key loader is marked as allow foreign keys. This means the key loader can take in any key and will update the properties that it governs to hold the properties that this new key contains. Think of a vending machine that uses those spiral rings and they push their wares out into the dispensing tray below. I mean, you can put anything in those. So to echo this once again, if you have a property definition set up to correctly handle taking in and spitting out a type, a string, a boolean, a coroutine using custom serialization and deserialization, and that is the property that key loader A has, but key loader B doesn't, and key loader B allows foreign keys, then that property is added to key loader B if a key carrying that information is pushed into that system during runtime. Get properties does a similar thing where it will first parse the properties list and look for a match. If no property is found that matches the name, the method proceeds to log a warning about the missing property, and then logs all properties available in the list, indicating their types and values. After this, it returns a default value, which is the default value of type T. Example, nulls for reference types or zeros for dynamic types. If it does find something, then it tries to convert that data into a casted type. This conversion is attempted using the convert.changeType method, which attempts to convert the given object property.value to a specific type of T. The change type method is versatile and can handle many kinds of conversions between compatible types. It uses the iConvertible interface implemented by many base types in .NET, allowing for conversions among common types like integers, double strings, date time. Custom deserialization logic can go here in the catch invalid cast exception if you have complex data types like a hash set of coroutines that you want to retrieve. Finally, we have a utility method that returns an enum based on the type of generic it was passed. GetTypeFromValue T is a generic method designed to map the type of a given value, T, to a predefined enum called property type. This mapping allows the system to handle property values consistently and to store them in a way that aligns with their data types. This is crucial for serialization and runtime checks. This method is designed to be easily extendable. As new types need to be supported within the system, additional if statements can be added to the method to handle those types. This design promotes clean code practices and makes the system more maintainable, as adding support for new types is as simple as adding a new if statement and an associated property type enum value. That is your setup phase, but past this, any keyloader you design down the road can access any of these properties. We have seen a few cases where we define our property definitions, and now we get to take a look at the actual class. Warning, high-level mage coming on through. This high wizardry class serves as a blueprint for creating individual properties. Each property can have different types of data associated with it. Numbers, text, list of items, and the class handles all of these possibilities through a unified system. As stated earlier, the definition names can be either a predefined enum or a custom string. Both get checked, and the one that is filled out gets pushed to its true name, property name. It will bias to custom names, as it's assumed if you fill out that field, then that's the name that you want that data to live under. Property type is an enum to strongly cast the types of data that any keyloader in your system can use. Pardon me while I take off my robe and wizard hat. In our public object value, we use a built-in switch in the getter and setter to look at the type being passed in, and can then make an informed decision as what variable to return. So a type of bool will return the data stored in the bool value variable. This includes casting in the getter. But wait, what's that, Ross? Casting again in my wizard's tower. Yes. Having type-specific fields in property definition and allowing for dynamic type requests in Property Manager provides flexibility and robustness. Property definition ensures data integrity and type safety internally, while Property Manager allows external users of the properties to work with them in a type-agnostic way, requesting whatever type they need. This lends to layered architecture, where low-level data management ensures strict type safety, and higher-level interfaces provide flexibility. It helps in maintaining complexity and maintaining a clean separation of concerns within the system. We conclude the class with the fallback value to return the correct or custom response in a fail state of the system. This way, an expected integer doesn't return a null, or an expected coroutine doesn't return a string. We have a set value function that sets a value, and then we have a function that determines the type of return based on the generic data it examines. This returns the enum of property type based on what it can cast that generic data as. I'm very behind on stuff. So normally I would go and say, hey, this is my email. This is my Ko-Fi. Tell me, watch out for my book. I'm making a video game. No, actually, I'm now making a video game to demonstrate KLEP in a real world, setting. So that's a thing. Watch out for that. I wish I can cover more, but I'm really cutting it close on this video to get it out on my 7-day schedule. So thank you for your time. Thank you for your interest.